Hi dear students, let's see this question that came in KVPY 2019 SX part 2 physics paper. Okay, so basically there's a let's see what's happening over here first. So here is a tank. Okay, so they have shown a closed tank, but actually we'll have to assume open tank. The reason is that we will have to apply the Torricelli's equation over here, and that can be applied only if the pressure above the free surface of the water and the pressure outside is same. Okay, so here pressure is P naught, so here also pressure should be P naught, and that will be possible only if the tank is open. So remember that here we will assume that tank is open. Okay, there are a lot of assumptions that we need to make in a KVPY paper which they don't mention explicitly. Okay, so remember, this is an assumption that we are taking, that the tank is open. So now what's happening over here, at a certain instance the height of the water in this is 5 meters. Now this of course will change with time. The base of the tank is at a distance as at a height of 5 meters from the ground, and there's an opening which is at the bottom. Okay, so this is at the absolute bottom, a small cross section opening. So water will be coming out from this and falling on a bucket, and we need to find the velocity of the bucket on the ground so that the water that falls down always strikes this bucket. Okay, this cross section area A naught has been given as 500 centimeters square, and this area A is given as 5 centimeters square. Gravity is 10. So we have to find the velocity of this bucket so that the water coming out always falls on this bucket. Okay, so remember, as I told you, we will assume that this tank is open, then only we can apply Torricelli's equation, because in applying Torricelli's equation, pressure outside the opening and pressure above the free surface must be same. Okay, then only the Torricelli's equation can be applied. Okay, so now, and also one more thing is there, the areas ratio should be very small. That means the area of the opening should be very small in comparison to the area of the free surface, which of course is holding over here. So we need not worry about that. But this thing is not given, so we assume that the tank is open. Now let's see how do we do this question. Okay, so let me draw the situation over here. Let's say at any instance the water left is of height small h. Okay, and it is falling and striking this bucket, and let's say this distance is x. So by equation of trajectory, we can say that this distance is capital H. So displacement of the water in the y direction is capital H. So y is equals to x tan theta. Now tan theta is 0, of course, because theta is 0. So x into tan 0 minus, we are taking downward is positive, so we can say it will be plus, or you can write here minus, it will be same thing. If you assume downward is negative, then here minus h will come. So x tan 0 minus g into x square by 2 into initial speed. Now what will be the initial speed of the water coming out? That will be velocity of efflux. That means the speed with which water comes out of the tank. So we know that that is equals to root 2 gh, root 2 into gh, where h is the instantaneous height of the water remaining in the tank. Okay, so 2u square cos square theta again is 0. So if you see this, this becomes h is equals to gx square upon 2 into 2gh, 2 into 2gh. Okay, now if you differentiate this, basically you can take this on the right side first. 4gh into capital H is equals to gx square. Okay, now if you differentiate this, let's go on the next slide. 4 GH is equals to gx square. G anyway will cancel out, so we don't need to carry it anymore. Now if you differentiate this, so 4h into dh by dt. Okay, dh by dt is equals to 2x into dx by dt. Okay, now dh by dt is the speed with which this surface is going to come down, right? So can we say that equation of continuity? So capital A naught is the area of the free surface into dh by dt. Okay, this should be equals to small, like this area of the hole into velocity of efflux, which is nothing but root 2 gh. So we can find the value of dh by dt from this equation. So a into root 2 gh by a naught. So this will become A into root 2gh by a naught. So A into root 2gh by a naught. This will be is equals to 2 into x ka value you can again find from this equation itself. You see that x is nothing but root of 4hh. So we'll put here root of 4hh into dx by dt. Dx by dt is nothing but speed of this block. So which is what we have to find. Okay, now this solves the question. H and h will be cancelled. Okay, what else cancels? This 2 and this 4 will come out and it will become 2. So 4 and 2. So it is 4 only cancels. Okay. Here root 2g is remaining or ये वाला h and ये वाला h will make it root h. ठीक है. This a by a naught is 500. नहीं 100 sorry. Not 500. A by a naught is 100. Yes. So this will become 100. ठीक है. 5 by 500 will become 100 and root 2g is root 20. ठीक है. This is the speed. Okay. H का value was 5. So this becomes root of 100 upon 100. That means 1 by 10. This is speed which is nothing but 0.1 meter per second. ठीक है. 0.1 meter per second. Okay, so answer will be option C, 0.1 meter per second. I hope you would have understood. So again, I am telling you, I have applied Torricelli's equation. So for applying Torricelli's equation, there is an assumption which we need to make, which is that here the it should be open. Okay, I hope you would have understood. That's it. Thank you.